So Hive is SQL data warehouse tool. Okay, SQL data warehouse tool. Okay, so Hive is similar to SQL. Any SQL, Hive is similar to any SQL database. Okay, so if I compare with the Oracle, MySQL, SQL Server, DB2, all these are the SQL databases. Okay, so all the features of any database is there in the Hive. Okay, but Hive is the part of Hadoop ecosystem component. Hadoop ecosystem component. Okay, so Hadoop ecosystem has various components are there. So the main components are the ingestion components. Okay, some are the analytics component. Okay, scheduler component. Scheduler is there. Okay, so here if I say ingestion, the two components are there in the ingestion: scoop and flume. Okay, scoop is used for structured data, right? We can import structured data, right? Oracle RDMS database data and any database, not only Oracle, RDMS database data into Hadoop file system. Okay, so I told everything like basically any ingestion, any analytics we want to do, we need the data in Hadoop file system. Without having the data in file system, Hadoop file system, we cannot do analytics. So Scoop is a one tool which can bring the data into. So it is an ingestion tool and which can bring the data from RDMS database to Hadoop file system. Flume is for unstructured data, for unstructured and semi-structured data and semi-structured data. So we know unstructured data, right? Audio, video. So this kind of data is unstructured data, audio, video, images, photos, right? So these are the unstructured. What is semi-structured data? XML file, CSV file, JSON file. So this kind of data. So there is a Flume is the tool which can bring the data in Hadoop file system into Hadoop file system, Hadoop distributed file system. Analytics tool we have MapReduce. So MapReduce is in Java. We write a Java code. Okay, MapReduce we write a code in Java, and there is another tool is there Pig that is using Pig Latin script. Okay, it is ETL tool. Okay, but we are not learning Pig because nowadays it's obsolete and nobody is asking on the Pig. Okay, so there is no new version of the Pig in the market. It's an old version is 2017. So last version release is 2017. Okay, so that is the reason we are not doing. Another one is Hive. So Hive is a SQL data warehouse tool. SQL data warehouse tool. So for learning Hive, somebody should have the knowledge of any SQL database, like basic SQL knowledge, like SQL queries, joins, union, and group aggregation function, group by aggregations, right? And windowing function. So these all things are used in the Hive, okay, which are there in the SQL, okay. And the scheduler tool is there, Uji. So Uji is a scheduler tool in Hadoop ecosystem component that is used to schedule any job, okay, schedule any job. So far we have done MapReduce, okay. So MapReduce code is written in Java, right? We write a Java program to do the analytics. But Hive, we are using SQL query, and Pig, we write ETL, okay. So there are some operators are there in the Pig, like load operator, dump operator, okay. So these are the ETL type of operators are there. Those we use in the Pig, okay. And SQL, we use SQL query. Similar to SQL, we write a same SQL query in Hive, okay. So first is Hive is originally created by Facebook, okay. And later it is given to Apache community. So Apache community is non-profit organizations, right? So when it is given to Apache, so it is given Apache Hive. So now it is a Apache Hive. Okay. So it is a part of Hadoop ecosystem components, and Hive is the one SQL data warehouse tool. So for SQL data warehouse tool, we should have SQL data warehouse. We should have the knowledge of data warehousing concept. Data warehousing concept. So data warehousing concept is like what is a fact table, what is a fact table, dimension table. Okay, there is a star schema, star schema, snowflake schema, and SCD, slowly changing dimension. Okay, slowly changing dimension. So whenever the data is keep changing, right? So we can maintain the history. Okay, that is coming in the slowly changing dimension. So this is all theoretical concept. Okay, I will tell about these. These are the theoretical concept, and this is the part of Hive to understand. But these are basic fundamental concept of data warehousing terms. Okay, so when we come to the Hive, so Hive architecture. Okay, what is a Hive architecture? So Hive is having itself small components are there in Hive. Okay, so Hive is having one CLI. CLI is command line interface. So where we write a SQL query, that interface is CLI. So you will see one prompt like this, Hive prompt. So here you write a SQL query. Select star from employee and semicolon. So like this, you are writing a query, and this is called Hive CLI. Another component is Hive is having database engine. Okay, so database engine is internal to Hive database engine, which is executing your query. Okay, before that, Hive is having compiler. Okay, Hive compiler. Okay, first we say parser, and then Hive compiler, and query processor is a database engine. Okay, so parser is parsing the file, parsing the query, and compiler is compiling the query, and it is converting the query. After compilation, it will generate a MapReduce job. So this MapReduce job we are not writing. This MapReduce job is generated by the compiler engine, like database engine, not here. Database engine. So database engine is basically generating the MapReduce, and this MapReduce is executed on top of the SDFS and getting the result from the Hive table. And one more thing is there in Hive is meta store. So Hive is storing the metadata in this meta store DB. There is a separate DB is there. That name is the database is Derby. Derby is a Apache Derby. It is a small SQL database. It's a small SQL database which is given by the Hive by default. Okay. So in this database, it is storing the metadata, and this metadata is data about tables, or you can say the data is stored in the SDFS. Data is stored in SDFS. So that information is there. So there are the two types of table. I will tell later whether the table is a managed table or external table. Okay, internal table or external table. So managed table or external table type or table name, column names, column types. So this all metadata is stored in one table in this metastore DB. So this metastore DB is a DB name. Metastore DB is a DB name. Metastore underscore DB. So metastore underscore DB is a DB name. Okay, and that is where this is the SQL database, and this is in Derby. This metastore DB in Derby database. Okay, and this is containing only the information about the tables. So Hive tables have the information about their metadata in this form, like what is the type of the table name, column types. All these are stored in one table, that is name is TBLS. This is the table name is stored in metastore DB, metastore underscore DB, this database. Okay, and one more Hive component is there, Hive Thrift server. Okay, what is the use of this Thrift server? Suppose I have my reporting tool Tableau. Okay, Tableau is a reporting tool. in Windows. Okay, and I want to connect this Tableau to Hive database. Okay, so this thrift server is a mediator, right? It's a like a middleware, right? It's a mediator which can connect Tableau to Hive database using Hive server 2. So Hive server 2 is a thrift server name. Hive server 2 is a thrift server name. It is a thrift server name. So thrift server is a very common name. Generally, it is used for the cross platform and cross language. When you want to connect one platform to another platform or one language to another language, that thrift server is used. So what is a thrift server name in Hive? Hive server 2. So anybody ask you what is a thrift server name in Hive, that is a Hive server 2. Okay. And main Hive server is this database engine is a server 1. Okay, that is main query parsing tool, right? And generating the map reduce tool. Okay. So this is the one Hive thrift server. Okay. So that is also one component. Okay. So this is all about the architecture of Hive. Okay. So first of all, in Hive, what we do, the very big term we say database. So what is a database? Database is a collection of tables. Collection of tables. Okay. So we say like I'm creating a database. So my database name is my database 1, and I'm creating a table. So I will create a tables. So tables we know it's a tabular representation of the data. Tabular representation of data in rows and columns. Okay. So we know these rows are called records, and these columns are called fields. These columns are called field in terms of Hive. Field. Okay, same terminology, nothing difference. Okay. So when I say like I'm creating a database, and inside the database I'm creating tables, then I can use command to see the database, like use database name. Then I can go inside the database, and then I can do show tables to see all tables, and particular table I want to see, data select start from table. Okay, so these are very common commands we use. Okay, suppose I want to create a table, so create table command is there. Then I say name is a string type. So here is a string also type is there. We don't use varchar here. We use in Hive string. So varchar and varchar2 in Hive is string. Another field like age is an integer type. Okay, okay, Sally, I can say double type. So all the fields are there. Okay, okay. But in Hive, some extra complex data type also there. These are the primitive data type. Okay, so two types of data types are there. Data types. So one is a primitive. So primitive data type, we know those are very common data type, primitive data type. So like string is a primitive, integer is a primitive, and double is a primitive. Okay. But another data type is called complex data type. So Hive is provided three complex data type. One is array, second one is a struct, and third one is a map. Okay. Array is, suppose I have to store 5 values of same type. So one way is how many int variable you have to create. If you want to store 5 values, so you have to create 5 int variable. Okay. So it is not easy to maintain, right? All 5 variables, right? So if I create array type like this, like when I'm creating a table, create table employee, and I say student has the 5 subject marks. So I say subject, let's say marks of integer type. So I can store any number of, and suppose I say my address is a struct type. Okay, here is coming like this. The array type I'm defining, and that is int type. And when I say struct type, so struct type I will define different data types. So what is the difference between the struct and like I say street is street is a string type. Okay, I say house number is a integer type. Okay, so like this I can give different types that is basically define the struct type. So struct type has a combination of different type, and array is a combination of same data type. So like if I'm using a marks, right? So all 5 subject marks will be integer type. Okay. And another one more type is there, like map. So map is a key value pair type. So I say department, I can say map type. So map is having two things, key and value. So first one is a string and second one is a string or any combination, integer or string like so. But it is a combination of key and value. Okay. Okay. So this thing is clear so far.
Yes.
Yes. Okay. So Hive installation. For Hive, when we want to run Hive, we first of all we have to run Hadoop, because Hadoop is a prerequisite for Hive, because we cannot start Hive without Hadoop. So Hadoop is needed. Okay. So first we have to start the Hadoop. So my Hadoop service is already running. And if I check my Hive, if I type Hive, so right now it's saying Hive is not there. Okay. So it means it is good, like Hive is not there. So I can install in front of you. So here, softwares. Okay, Hive is not there. Okay, I have not installed Hive. Only Spark and Hadoop I installed. Okay, so I follow the same steps, so then you can see and you can install the same way. Okay, so I'm going to the URL Hive installation 1.2, and you have to follow the same link. Okay, so first JDK is needed. Okay, so Java we have already, because we have already installed Hadoop. So Java is already there. Okay, so next thing is we have to download the Hive zip, right? The software Hadoop Hive we have to download. So we have to go to the official web page of Hive. Okay. Okay, we can find it here. They have changed the URL Hive download. So it will give us yeah, these are the releases. So 3.1.2. Okay, any other newer version? Okay, we can see like this. What is the newer version? So see 1.22, this is old, 2.3.9 it is old, 3.1.3 is latest, and 3.1.2. Okay. So any version we can take it, but 4.0, this is alpha version. So this is the like it's not we right now use. Okay. So I take it this one 3.1.3, and here I have to download this binary tar file. So I clicked on this, or we can do wget command also. Right click and then copy link address, and wget you can do, and then you can get it download the zip. They have done the same thing. So here they have done wget. So you can paste it your new URL. So you can do wget and this URL. This URL we have to copy. This URL. So you can directly download in the software. So first it came into my download folder. So here I'm extracting it. Okay, so this is my complete Hive folder. So I will rename it so that I can remember the name. So I will keep it till here. 3.1.3. Okay. And now I will copy this folder, my software, because I'm keeping it all my installation in the software folder. So software folder, I'm keeping it here. Same like Hadoop, we set the bash RC path. So I will be setting here nano PASHRC. So I will go on the bottom. So here I have to copy the hive path. This one I have done. Okay, nano bash RC. So I'm copying this one. And I will copy here this new path. And what change I have to do here? 3.1.3. Okay, I'm not using the bin, so remove it. Okay, and here is, this is a mistake here. Slash will come, and then my username will come and software will come. So admin slash, you can change accordingly your one softwares, and then Apache Hive 3.1.3, and this is, there is no change because this is a path. Okay, so Control X, Shift Y, enter, and then we will run the source command PASHRC. Okay, now it's done. Okay, so this is, I set it. Now next thing is change Hadoop path. We have to set it in. There is a hive env.sh file is there. So hive env.sh file, we have to copy this export path. So this path also I have to change because here is a different username. Okay, so my Hadoop name is Hadoop 3.3.4. Okay, so I go to Apache Hive here, bin, and there is hive config.sh. So here I will add this export. Okay, so here in this export, my username slash softwares, and my Hadoop name, folder name is 3.3.4. So I'm using 3.3.4. Okay, so this one I've set it. Okay, so this is done. Hive config is done. Now next is, it is saying to create a temporary directory on Hadoop. Okay, so just as it is, this command we have to run for Hadoop directory. So I just paste it. My Hadoop is already running, so it will create a one directory. So it is already present. So it is, I have to, so I don't need to create. Okay, because in my case it is created. Okay, and I have to give permission, chmod permission. So this all Hadoop command we are using, chmod command. Okay, so I've given permission. Next is create a warehouse directory. So I have to create a one warehouse directory. This is the warehouse directory. Your internal table will be created. An external table will be created outside the warehouse directory. So this warehouse directory, we are creating. This warehouse directory I created, and I have to give the permission to warehouse directory. So what is the permission command? So this is the same like a chmod g plus w. Okay, so g means group and plus w means write permission. So I'm giving a write permission so that I can create a table inside this directory. Okay, g plus w, we can write permission. So this is done. Okay, so this is just doing list, right? So we don't need to do this. So this is done, and now we have to do some configuration. So in our config folder, bin config folder, here is one hive env.sh and hive default XML template. So this files we have to rename it hive site.xml. To make it hive site.xml, and this template things I have to remove. And this is also I have to hive env.sh. So I just remove this ivnb.sh. So this rename things I have to do. So I have to change it like they are already doing here, hive default.xml to hive site.xml. Okay. So this is command line they are doing. You can directly go and rename it. Okay. And this all things are fine. Okay. Here is they are telling about what is a warehouse directory. So this is a default path. It is already there. If you want to check in hive site.xml, so we can check it. Okay, what is the property name? Hive metastore warehouse.dir. Okay. So I open the hive site.xml. Restore. So see, already it is set user hive warehouse. So we don't need to set because that is the reason we created this name directory. We created directory in Hadoop with this name because already the default path of the warehouse directory is user hive warehouse. This is internal DB and this is a Derby. You can see here. Okay, this is a Derby. So we can create our own metastore DB in some other database, right? Like Oracle, MySQL. So here also I can create, right, my metastore DB. So I have to change the DB type. So whichever DB type you want to change, you can change here and you can change the URL and username, password of that metastore DB. We can change. Suppose I'm keeping it my metastore data in Oracle or MySQL. So I have to change the information here. Okay, so then my hive site.xml will connect to that particular database. But default database is Derby that comes with Hive. So no changes we have to do if we are not changing the metastore DB. Okay, so this thing is done. Now next thing is we have to run this command, schema tool command to generate the database schema. So I just run this command. Schema tool is there, DB type I'm telling here, this is my Derby is a metastore DB and init schema. So I want to initialize schema. So here is this dollar will come because hive home is a variable, right? That is your environment variable. So I have to use it dollar hive home. So this error is coming. It is giving some error on the 3215 line number 96, right? In hive site.xml. So we have to go to hive site.xml 31. What is the line number? 3215. 3215 we have to go. This error will come for everyone. Okay, so that is a fix I'm telling you. So you have to go to line number 3215. There is some special character. We have to remove that. 3215. Here. So this is a special character which is giving the error. Okay. So this error actually Hive, who has provided this Hive chip, right? So they have to fix it, but they haven't fixed it yet. Okay. So just we have to remove those special character and save. And again, we have to run the same command. Okay. So this time our schema is initialized. This Derby schema is initialized. Okay. So this part is done. Now, okay, now we type hive to start hive. Okay. So let's see hive. Okay. So this error also coming. This is the error is temp dir. This error has not come. Okay. That is the reason I skipped it. So this error comes, somebody's come like some error, library error. So you have to replace this 19.0 jar to 27.0 jar, and this jar is in the Hadoop library. Hadoop library, this path, and we have to copy to Hive library. But this error we didn't get it. We didn't get this error. When we started Hive, we got the another error. We got it because that error is not coming in this one. So this error is coming, this system IO temp dir. So copy this one, system IO temp dir, copy this one and find in this hive site.xml. It will be 5 places. So what you need to do, wherever in properties this thing is coming, whichever property it is coming, just remove those property. So I'm removing this property, but make sure like whatever property is starting, the property is ending. So don't you should not delete the previous or next tag, okay, of property. So just property to property, where is the property starting and property is closing, just remove that one. Okay, this is the one place we remove. Now second one is this one. So here is property starting and property is closing. We removed it. Again, find it. This is two places are there together. So property starting, property is closing, property starting, property closing. We removed it. And this is now final one. This one. This is the final one. And this one is a starting and ending. So I have removed all the one and save it. Okay. Now I start Hive. So you will get the Hive shell. Okay. So same Hive shell is coming, which is coming here, right? So now this installation is done. So when you are checking this Hive shell, now you will say show databases. Show databases. So when you say right now, the default database they give. So for any database you want to use, so you have to use command. So I have to create my own database. Even you can use this default, but there will be nothing. Use default. And now show tables. So there is no table. Okay, so if I want to create my own database, so create database and I say testing. Okay, now I say show databases. Testing is there. Testing is there, default is there. So I want to use the testing one, use testing. So now I'm in testing database. Okay. So there is a command to check which current database you are there. How to check current database in Hive shell. Some command is there that can show you are in which database currently. So when you do use and select current database, okay, this command is there. So when you run this command, so you will come to know in which database you are. Select current underscore. Yes, select. Function is okay, I will check it. So this will tell you which database you are there. Okay. So once I create the database, I will use the database. Okay, I already used. Now I do show tables. So I will see there is no table, right? So I have to create a new table. So I have to create a new table. So there are the two types of tables are there in Hive. So one table is internal table and external table. Internal table and external table. So internal table, which is created within a warehouse directory, user/hive/warehouse. So that table is called internal table. Okay, internal table. Okay, and or we call it managed table. Okay. So one point with this internal table is when we drop this table, we drop means we delete this table, we drop this table, internal table, internal table. So schema and data. Every table is associated with two things. So table is associated with two things. One is a schema and second one is a data. Okay. So schema is defining the structure of the table, like what other columns are there in the table. So that structure is called schema. And data is like data which is populated in table. Data is populated in table. Okay. So when you are dropping the table, internal table, in that case, schema and data both will be deleted. Schema and data both will be deleted or dropped it. But in case of external table is outside the warehouse directory. Outside the warehouse directory, you can say any Hadoop location. Any Hadoop location outside the warehouse directory. Any Hadoop location. Like SDFS, it will be SDFS, but outside the warehouse directory. Okay. So external table, use the external keyword. When you create table, you write create external table. Like this keyword you have to use to tell whether this table is the external. And one point with the external table is we drop external table only schema will be deleted. Schema will be deleted, not the data. And tables can be recreated. Again, you run a create table command. Like you can same schema, you can create table again. So table can be recreated by creating table with the same schema. So wherever the data is residing, right? If you are not changing the location of your table, so it will associate. So when you drop table, it will detach. It will be deassociated. But when we create table again with the same location, it will be associated. So your data will become associated with again the same location. Okay. So external table, we will not drop the data. Only the schema will be dropped. Only schema will be deleted. Okay. So how to create table? First, I show to you like creating an internal and external table. Okay. Internal and external table in Hive. Okay. So just to take an example. This create table test. How many columns are there? 2. ID and name. ID is an integer type and name is a string type. And when we create a table, we have to use in Hive row format delimited, field terminated by comma. So this table is associated with some data on the disk on Hadoop file system. So that file is having the data is comma separated. The field is a comma separated. So your data is a comma separated. So that is the reason they are giving row format delimited. Your rows are terminated by /n. By every row is a new line, and the field terminated by comma. So this is we have to give in the even the for external table also we give the same thing. But only difference is here this location thing we are not giving here. But when I create an external table, I have to specify my location. So when I show you my external table, so here in the external table, I have to give the location. So here I'm giving a location. Okay, everything will same, external keyword will come and location will come. So this table will not go to the warehouse directory. Okay, so I just show you the example how to create a one internal table and how to create an external table. Okay, so here, okay, I'm already in my database, right? I have done, here is no table now, show tables. So there is no table now. I'm creating a first table, test. Okay, so now I do show tables. I can see my test table is created. Suppose I want to see the schema of the table to describe test. I can see the schema. So how many columns? 2 columns. If I want to see complete table command, again I want to see this table command. What table command I use? So there is a command show create table and table name. So show create table command will show you a table command. Which table command you use? So here you can see the location user hive warehouse testing.db. So testing is a database. So it is assumed that this database is testing.db is a database and test is a table. So what a file, this test is a directory. So this directory will contain your file for this table. Okay, Abhi, right now this location will be empty. Okay, and one more thing is when I want to run any Hadoop command, I can run here by using this exclamation. So this location, suppose I want to see what is their data inside this one. So I'm using exclamation mark. Okay. To run any Hadoop command, you have to use exclamation mark. Okay, and test and semicolon. Okay. Okay, so one mistake is there. Directly we don't need to give, we have to give complete command. Hadoop fs minus ls. So we have to give the command like this because we are running Hadoop command on hive shell. So we have to use exclamation. Otherwise, I can run directly by using Hadoop fs minus ls slash, and then I will be using my path. So I will give the path test. Okay, so can you see here? Nothing is there, right? When I run here in hive shell, nothing is there. Nothing came, right? No, nothing is there, right? So it is empty directory. So right now, if I do in my hive shell, select star from table. My table name is test. So what it will come? Nothing, because nothing, no data is loaded. So first I need to load the data into my table. So I will load the data. I will create some file here and I will load the data. So I say test.txt. Some file name you can give anything. Test1.txt. So what is the, okay, already this file is there. I create internal table, internal.txt. And now how many columns I have to create? 2 columns, right? So 2 files, two fields I have to give. So first is ID and name, ID and name. So I'm giving ID 101 and name is XYZ. 102 test 1. 103 just sample data I'm taking. Okay. Now escape :WQ. Now this file is in my local file system. What is my path of this file? home/Arvind this path is there. So I will write a command here in my hive load data local. Why I'm using local? Because local file system I'm loading in path, and then I give the location of my file home Arvind internal.txt and into table, and what is the table name? Test, into table test. So now data is loaded. Okay, and now I do same select star from table. I will see the data is coming, right? So this is the one way. Now, if you see your that file location, if you do this Hadoop fs command again, so you will see here one file is copied. Can you see here internal.txt? So this file is copied in this directory. So this is the one way you have loaded data through Hive. If I say, okay, if I drop this table, drop table and test, what will happen? Drop table test I did. Now if I do select star command, there is no table. If I check my location, if I check this location, so it is also giving error because no file directory. I told you data and schema both are deleted. In case of internal table, your see testing.db will be there because that is a database. But inside this table /test, that is deleted because it is a internal table. So in case of internal table, your schema and data both are deleted. Okay. So now I'm creating a table again. So here, so I'm just creating a script again, table again. So this is my Hive shell. I'm creating same internal table again. Okay, now I check. It is not giving error because whenever I create a table, this directory is created, but still it is empty because this is a new table. Again, I created new table, but this time I will not do this command. I will not do load data local in path command. What I will do, I will put this file. This is a Hadoop directory. I know this is a Hadoop directory, right? Where is this table is created in the warehouse directory. So I will put in this directory, and this directory I will put the file. So how I can put, here is my file. Internal.txt is there, right? Ls internal.txt. So this file is here. I will use the command hadoop fs -put and this internal txt file. Which location I have to copy? I have to copy this one. Even I don't need to give this entire one. I can give this one, testing.db and test. I have to copy this one. This is my target path. Okay. So this target path, I'm giving my location, this target path. Okay. And then enter, because the file with the same name will copy in this test directory. Okay. File is copied. If I want to see this command, okay, hadoop fs -ls. So my file is copied. I just copied the file, but I didn't do anything in the Hive, right? And now I do select star from table. Select star from text. So you can see data has come. So either way you can do, either you can load the data in Hive shell, or you can copy the file in your target directory, the table directory test. Okay. So if you copy that file, your data will be populated because it is automatically parsing the data from the file, because your data is a comma separate. If you change your delimited character in your file, suppose your file is there, this file. Okay, I just delimited character I change. So what happens? I just change this one to space I give. Okay, like this I give. Okay. So W2. Now again I have to put the file, overwrite the file, right? File is there. So I have to put the file, I have to overwrite the file. So -f option I have to use, right? Because I want to overwrite the file. So -f. So I will be overwriting the file. Okay. Now in the Hive, again I do select star from test. So whichever row is not matching with the delimited character, it is giving null value, but it is not giving error, because hive is schema on read. At the time of writing the data, it is not checking the any validation. It is not doing validation whether my data type is correct or wrong, or my field delimited is correct or wrong. It is not checking. It is just blindly insert, right? It just if it is giving issue while the time of reading data. Okay, so writing a file is not giving issue, right, in the hive table. But when you are reading the data, when you are doing select query, then you will get the issue. Then your validation will be done. So hive is schema on read. So hive is schema on read means it is checking data type validation at the time of reading data, selecting data, reading, selecting data, not at the time writing data into table. Okay, but SQL databases like Oracle, MySQL, they were not allowed to write the data. So they will fail at the time writing data into database table and give the error. Okay, that is the reason the inserting data in hive very fast. So I showed you 3 record, but even you have 100,000 records, seconds it will insert it, because nothing checking, right, it is doing. Okay, so hive is schema on read, but SQL databases like MySQL, these are schema on write. Schema on write means it is checking schema at the time of writing into table. Here checking the schema at the time of reading the data. So hive is, so this is the main difference between the hive and SQL database. But if you say the structure wise, everything same in the hive and SQL database. Okay, now I show you the external table case so that we can wind up. So is SQL, this external table is, so one internal table we seen, like schema and data both are deleted. So same command which I told you, load data local in path, we can use. Even CSV file data also we can load, anything we can load, right? But field delimited character should be correct. Okay, suppose you want to load the data from the pipe delimited file. Suppose your fields are separated by pipe. So simply instead of this comma, you make it pipe. Okay, suppose your fields are terminated by dollar. So just make it dollar. Okay, so just make sure whatever delimited character you're using here, the same delimited character should be in the file. Otherwise, it will load the data null. Okay, so when you are using the drop table command, so I showed you the schema and table both will be deleted. But in case of external table, like I'm creating an external table, this one, and I'm giving a location, some Hadoop location. Okay, if this location is not present, it will create automatically. Okay, so this, because this will not create a table because already the table name test is there. So I just create another table name test1. Okay, so I'm just making it name test1, and I'm just copying this, creating a table test1. So what is the location of this table? Show create table and table name test1. So you will see here the location is coming whatever location you given. So here is a Hadoop location / table data. So this is my root directory, and there is a, this directory is created. This table data directory is created. Okay, so if I see Hadoop directory, Hadoop fs -ls /, so here in the root, this table data directory is there. Can you see here table data? So this is created today, 23. So this table data directory is created. Now I want to load the data. Load data process is same. Either you do internal table or external table. Okay, so I can load the data from the same command. Okay, I can use load data local in path /home /arvin /internal.txt. I am not creating another file, same file, into table name. Table name is test1. Okay, so data is loaded. Now I want to see the data. Select star from test1. Okay, so same data is there. So why it is a error, this null? Because I have not corrected the file, right? The file is still same. So I can modify the file. This one. And I will add some more record. Suppose if I give something extra also, what happens? $Q. Okay. Now I'm loading again data, right? Hadoop fs minus put. So this is second way I'm doing, right? I'm just overwriting the file, okay, by using this. So, okay, now I do my select command, test1. Still it is coming old one. Why? Actually, this one I am just overwriting in the warehouse directory, but my directory is not a warehouse. This is my mistake, right? So I have to change to the actual location of this table. The actual location of this table is this one, table data. So table data is the location, table data. Okay. So I have to copy it, table data. Table data. Okay. So I have overridden there. Now I check now, select start from test1. Now you can get, so only it is taking first second, right? 104 test 123. So what data I inserted there? Test 123. So this last one it is not taking, right? Because in schema only two columns are there, ID and name, right? So this will not be accepted. Okay, so it is ignoring. Okay, and now I can see my table, I can see my data. Okay, so Hadoop fs minus ls slash table data. Okay, so here is one file is there, internal.txt. Okay, so this file is there. Now I'm going to drop the table, drop table test1. Okay, first I check the table, select start from table test1. So it will say table not found. If I check the data like this, data will be there. The data is not deleted. The data is still there because table is dropped, but data is not deleted, right? So same command, if I run it again, this command, I create a table again. I run it on the hive shell again. Okay, again I do select star from table. Now the data will come. So you have associated, deassociated. So when you drop, your data is detached, but it still is the same location. If you are changing the location, so it will be a new location. So, but I'm giving a same location. So wherever the data is residing, this data is present in this location, it will become again associated with this table. Okay, this concept is clear. So I will share this link. Okay, and this command. I will prepare this all this internal table and external table command. I will prepare in this notepad, and then you can practice with the create database and those commands. Okay.
Okay, sir.
I'll share the recording. Okay, in half an hour. Okay.
Thank you.
Yeah.
Thank you so much.
Thank you.